Hello everyone, it's been a long time since we did max, so we're gonna do max, our second chapter, the continuation. So today we're gonna do functions, that what types of functions are there in this chapter. So before we start, please subscribe, share, like and comment on this channel. Now our first function, our first function is identity function. What is it? Identity function. It is described as r is r by y, which is f of x is equal to a. So here for each x that belongs to r, the domain and range should be equal to r, and that f of x, right, that function of x will be equal to x itself. And there is also a graph for this. You can see around here that where the line is passing through, that f of x is passing through the o. Okay, you can see it's a straight line, and but it's passing through the origin. So it is said that the f of x is equal to x itself for each x belongs to real numbers. So the domain and the range itself will be real numbers. So second function is the constant function. So the constant function here, r is r by y, which f of x is equal to c. So where the c is a constant, okay. So here x belongs to r. So what will be its domain and range? Here the domain will be the real number itself, but the range will be set c. So here you can see in this diagram here where the line is going. Line is parallel to x-axis, so which means that c, that is the y, will remain there for a long time, but the x's, right, from the domain will all be different types of real numbers. Now next function we're going to do is polynomial function. So in this function, r is r by y, which y is equal to f of x, which is equal to AO a1 x raised power 1, then plus a2 x raised power 2, plus so on to an x raised power n, where n is the non-negative integer and a1 all belong to r, so on to an. So you can see the diagram of this polynomial function. Next function we have is a rational function. Here in this rational function, f of x by g of x. In this we have two functions here, which is in the division form, where f of x and the polynomial function x is defined in a domain where g of x is not equal to 0. So this they saying that the f of x and also the polynomial function x will be defined in the domain where g of x is equal will not be equal to 0. So the domain, what will be? Domain will be r except 0. Even range also, all the real numbers except 0. So both these range, the zeros are not to be there. You can see in this diagram here where the line is passing through. And what's more, it's not even touching the O part, that's 0, right? It's not touching there. Next we have the modulus function. Here in the modulus function, r is r defined by f of x is equal to modulus x. Here the modulus means whatever be the number of the integer, be it -1 or 1, it will remain as it will remain positive. So here that function of this x will be equal to the modulus of that x for each x belongs to r. So for each non-negative value of x, f of x is equal to x. If it's negative, then also will be x. That is, for example, f of x is equal to, if it's positive, that is positive x, then x is greater than or equal to 0. But if it's a negative x, then x is smaller than or equal to 0. You can see in this diagram, no? Where the x's and the or the positive and integer. Next we have the signum function. What is the signum function? Here r is r defined by f of x, which is equal to, there are three ones given here, where it is equal to 1 if x is greater than 0, 0 if x is equal to 0, If it's minus 1, that means x is smaller than 0. You can see also the diagram, right, how it's going through. So the domain and range will be equal to, domain will be equal to real numbers, but the range will be minus 1, 0 and 1. That set itself, whether minus 1, 0 and all I just mentioned, no? That will be the range itself. Domain, all real numbers. You can see the diagram, right? Now next and last of all, we have the greatest integer function. So in this here, r is r defined by f of x, where it is equal to the x itself. So here x belongs to r, but we assume that the value of the greater integer number might be less than or equal to. So here you can see in this part, x is equal to minus 1. For minus 1 is less than or equal to x, but less than 0. And if x is equal to 0, then means 0 is smaller than or equal to x, but smaller than 1. So you can see all this, no? All this given here, all this x's, if you put them in the diagram, you will see like it's going like a staircase, right? Here is minus 2, minus 1, 0, 1, so on. So you have that line. So this is the end of the video. Please subscribe, share, like and comment.
It's caught in the crossfire.